Good morning, everyone. In the last class, we have discussed about what database integrity is and types of keys. Yes. So again, I'm brushing up the concept of database integrity. Or we will study it in little detail because to define these integrity constraints or define this integrity to achieve this integrity, differential integrity, and entity integrity, you have to know these points thoroughly. So what is database integrity? Database integrity refers to the validity and consistency of stored data. So the data which you are storing in the database should be valid. Valid in the sense it should satisfy the conditions or whatever rules you specify, and as well consistency. So what is consistency? Consistency. So what is consistency? So here consistency means, for example, I'm storing employee name in the database. So it is stored in multiple places. Yes. See, for example, uh, here I will show you. Yeah. Yeah. Here I will show you. Here the employee name is AAA, and his employee ID is his or her employee ID is 101. So wherever you find employee ID 101, the employee name should be AAA only, because only one employee exists with that ID. But if at some place, because of typing mistake or typographical error, you enter it as ABC. So what happens? It compromises the consistency of the data. It is not uniform all through the database. So if there is some change somewhere in the database, so it results in inconsistency. So if someone happens to retrieve that data from the table first, and next this in the from the first table. So what happens? First they will see 101 is equal to ABC. I mean, for 101 the name is ABC. But when they are fetching data from the other table, there they find it as 101 as AAA. So there arises a confusion. Which one is the accurate one? Which one is the correct one? So here the consistency is getting compromised. So in order to maintain the validity and consistency of the database, we follow some set of rules, integrity rules, and those are the things that we are going to discuss today. See, how this integrity is maintained or expressed, it is usually expressed in terms of constraints. Constraints are nothing but conditions, which are, or you can also call them as consistency rules, that this data has to be maintained like this according to this set of rules and regulations. So the database is not permitted to violate. So these are the rules which the database cannot violate. If it violates the data, the consistency of the data or the reliability of the data will be compromised. So constraints can be applied to each attribute, or they may be applied to relationships between tables. So based where these constraints are applied, your constraints are again categorized into uh, three varieties. Domain constraints, CDM. Domain constraints, entity integrity constraints, differential integrity constraints, key constraints. Actually, in our syllabus, we are asked to discuss about entity integrity constraints and differential integrity constraints, or entity integrity or referential integrity only. So, but I'm still explaining this domain constraint. Uh, we'll see key constraint whether it is whether it has been taught or not. Let's see next. See, integrity constraints ensure that changes. What are the changes generally you do on a database? Update, deletion, and insertion. May the data that changes made to the database by authorized users do not result in a loss of consistency. So when you are doing some operations on the database, whether it is updation or deletion or insertion, it should not disturb or it should not result in inconsistency. It should maintain the consistency of the data. How will this be achieved? This can be achieved through integrity constraints because the users don't know what the conditions are. So if they try to insert some data or delete some data by mistake or intentionally, they can't do it when you put these integrity constraints on the attributes or the relationship. So automatically the consistency of the data is maintained. So see, the integrity constraints guard against accidental damage to the database. So by mistake or by because of some errors, if you try to delete or try to update or try to insert the data which is not following the rules or which is not in accordance with the integrity constraints, then it will not be allowed into the database. So integrity constraints help us to protect the database from accidental damages. So this is all about your database integrity. Next, already I have taught you, we have seen types of integrity constraints. So what are they? Domain constraint, entity integrity constraint, referential integrity constraint, and key constraints. So what are these constraints? Let's see in detail. So domain integrity constraints. So what is a domain? Actually, already we have see, already we have discussed what a domain is. Domain refers to the range of acceptable values. To whom? To a attribute. To an attribute, you can take only this set of values. For example, if I have EID, sorry, my writing is a little bit poor here with paint. Sorry, this pen. So EID, sorry, age, EH, age. So when you recruit employees into your organization, you can't recruit, I mean, you can't take people who are below 14 years or 16 years of age and who are above 60 years of age. Okay, so this is what is a constraint for the domain. Domain for the age attribute is 16 or 16 or 60. That means you can take employees whose age falls between 16 to 60. Because after 60 it is retirement age and before the 16 it comes under child labor. So you can't take um, uh, or you can't recruit employees below this age and above that. So this defines the domain value for age column or age attribute. So I hope you understand this. So it refers to the range of values that we are going to accept and store in a particular column within a database. This is the definition of the domain. So domain constraints means nothing but definition of a valid set of values for an attribute. So you have to choose the values for that particular column from this set of values only. That is what is domain constraint is. So what are the data types for the domain? Can be string, can be character, can be integer, time, date, currency, etc. Whatever data types that are allowed into your database. The value of the attribute must be available in the corresponding domain. So when you're trying to assign a value to that attribute, you should check whether that value falls into that domain. If it doesn't, and if you try to enter, the database will not accept. Any entry which you make for a column should be available in the domain of the data type. Again, that is what we are saying. Any entry, any value which you get assigned to that attribute should fall in the domain. Next, see here. Here I have a table, employee table. I have 4 columns here: employee ID, EMP name, EMP salary, and EMP age. So IDs I have given like this, and names I have written salaries. So here salaries are I can check. I can put 2 types of constraints here. One, the salary should contain only integer values, but here true 0 ABC. This is not an integer value. Yes, it is a combination of integers, numbers, and alphabets, characters. So if you put it as varchar only, then you can accept such kind of values. If you put the data type of this column as varchar, then you can accept this kind of values. But for salaries, you can't accept varchar. It always should be integer values. And one more thing, I can restrict the minimum salary and maximum salary of my employees. Like minimum should be 10,000 and your maximum can be 75,000. If someone tries to enter values which are more than these, like minimum value 10,000 and maximum value 75,000, again that will not be accepted as the values won't fall within the domain. So this is about your domain constraints. Next, entity integrity constraints. Already we have seen what an entity is. So how you ensure that the integrity of those entities is maintained is by through these entity integrity constraints. So what is entity integrity? Entity integrity constraint states that primary key value can't be null. So your primary key value can't be null at any cost. Why? Because this primary key is This primary key value is used to identify individual rows in a relation. If the primary key has a null value, then how can you identify those rows? So, entity integrity constraint says that you can't allow a null value into a column which is defined as which is set as a primary key. That is what this entity integrity constraint is. So you cannot allow null values into primary key. Null value under nothing but 0. Null value is nothing but 0. So 0 can't be there in your null specifies whether it is 0 or I don't know. But actually when you are defining or when you are creating tables, when you assign a column as a primary key, when you set as a column as a primary key, for that you have to enter all the values in the primary key. You can't leave any field in the primary key as null. A table can contain a null value other than the primary key. So other fields, other values in other columns can be given null. When you, for example, if you don't know my name, I am given a ID. You know my ID, but you don't know my name or you don't know my salary. Then you can leave those fields as null. Why? Because they are not the primary keys. What is the primary key here? Employee ID is the primary. Okay. So see here. Here again the same table I'm using here. Here I have left this employee ID field as null, empty. So it is not allowed. When you try to leave it empty, the database will show you an error. It is not allowed because employee ID is defined as primary key. You can't leave it as null. So this is about your entity integrity constraint. So this is how you ensure entity integrity. Next, referential integrity. So what is referential integrity? The name itself is saying relation. It is a constraint which is put on the link or relation between the tables. See, referential integrity is used to maintain the data consistency between two tables. Here, entity integrity is related to only one table, one single entity. But here, referential integrity refers, it tries to maintain the data consistency between two tables. How? Let's see. Rules are made in the database structure about how foreign keys should be used to ensure that changes, addition and deletion in the database maintain data integrity. So referential integrity says how the foreign keys should be maintained or changed or added or deleted so that we maintain the database. So here the differential integrity constraint, what it says, if a foreign key in the table refers to the primary key of the second table, then every value of foreign key should be in the first table should either be null or present in the second table. So again, once again, I'm reading it out. If a foreign key in the first table refers to the primary key of the second table, then every value of foreign key in the first table should either be null or present in the second table. So in simple terms, that it states that foreign key should have a primary matching primary key. So let's see with an example, you'll better understand it. So see here, we have two tables here. One is employee table and the other one is department table. So in employee table, I have added a new column. In the previous tables, I have taken only 4 columns. Here I have taken 5 columns and I have added a new column, department number. So each employee works in one or the other department. So they have to carry one department number for them. So I have created another table, department table, which specifies the location of that department. So with this, for example, if it is department number 10, it is located in Hyderabad. Department number 15, its location is in Mumbai. And if it department number 20, it is located in Bangalore. Here, department number, this is table 1. See, table 1, table 2, you try to understand. Table 1, table 2. Table 1 is the employee table and table 2 is the department table. In table 2, department number is the primary key. And the same department number also exists in table 1, that is employee table. So that is referred to as foreign key. So what is the definition of foreign key? A primary key, a key in a table which is defined as the primary key in another table and which tries to uh, relate the two tables, which is used to find out the rows in the second table. Such a key is called a foreign key. Again, you have to refer to your foreign key definition. So here, see, this is violating our relational referential integrity constraint. Why? Because here I have only 3 values, either 10, 15, 20. Here repeated values are allowed. Here repeated because I am not saying department number should be unique because it is not a primary key. Primary key values should be unique. The other values can be repeated. So here I can have 10, 15, 10 or 10, 15, 20. But here there is a new value called 18 which is not existing in the second table. See, I don't have 18 here. I have only 10, 15, 20. So this number is not allowed as department number because it is not defined as a primary key of table 2, and in table 1 department number is the foreign key defined. So here I have entered a value 18, because foreign key will allow. But as this foreign key is a primary key in table 2 and primary key should contain all, I mean this key, this department number should contain all the values that are there in the department table. So it is not containing this value. So it is violating the referential integrity constraint. See, repeated values are allowed. So the 10, 10, 15, 15, 20, 20. If this A instead of 18, if you put it as some 10, then it is okay. Then referential integrity is satisfied. But here the referential integrity is not satisfied as this value which is present in the foreign key is not there here in the primary key of the department table. So what is our referential integrity constraint? It says that every value of foreign key in the first table should be present in the second table. Every value which is present in the first table should be present in the second table. See, this value is not present. So it is violating the referential integrity. Or if you don't know, the value, then you can keep it as null. See here, the referential integrity constraint says that the foreign key in the first table refers to the primary to the second table, then every value of foreign key in the first table should either be null or present in the second table. It can take null value. If you put here a null value, see here, instead of 18, I write here null. What happens is, for this particular employee, there doesn't exist any department, or else he is a new recruitee where he is not assigned to any department. So here you can give him the department number as null. But if you try to assign a value here which is not there in the department table, then it is not following the differential integrity and it will not take the value itself. It's not allow you to enter the value itself. So this is about your referential integrity and entity integrity, domain integrity. Okay. So I hope you understand this. If you have any doubts, please message me. Thank you.